Hello and welcome to today's lecture about action potential or neuroimpulses. Over here we have a neuron, and you know that there are various parts of neuron, but for today's discussion we are focusing on the axon portion of the neuron. This is the axon portion of the neuron. This is called axon. This point is called axon helix, and you know that axon helix is the portion or the point where action potential is originated. And once action potential is originated, it is conducted from the axon helix and pass through the terminal portion of the axon, and from there they goes to the other cell or adjacent neuron. So for more clarification, let's take a section of the axon. This is the section of the axon, and for more clarification present here, suppose this is the inside of the axon and this is the outside of the axon. And you know that at resting state, a lot of sodium ions are found outside the neuron, and the potassium concentration are much higher inside of the neuron. Look over here. These two stimulus do not have enough threshold value. These are not strong enough to produce or to reach to the point of threshold. So here nothing will happen or no action potential will be initiated. And if we consider this stimulus is strong enough to reach to the point of threshold, so it will resulting in action potential. So what happened here? Once the stimulus have enough threshold value, so action potential will be generated, and as a result there will be depolarization of the membrane. What is mean by the depolarization of the membrane? The voltage gated sodium channel will be open. The voltage gated sodium channels will be open at the start of action potential. So sodium ions will be diffused from the outside environment and goes to the inside of the axon. So it resulted in the more electropositivity of the inside of the membrane. So we will get depolarization of the membrane. And you know that the inside of the cell become more and more electropositive when sodium ion enter from the outside to the inside of the cell, and this depolarization will be continued, and it reached to the point where a state or the electrochemical equilibrium for the sodium will be reached, which is 52 MV for the sodium. This is the electrochemical equilibrium point for sodium. The 58 MV will be obtained. So what happened here? There is, due as a result of depolarization, the membrane potential will go off and reach to the electrochemical equilibrium value for the sodium. So at this stage, the potassium channels have enough voltage to become open. So here the sodium channel will be closed and potassium channel will be open. So membrane quickly regain its resting properties or resting state as potassium ion quickly diffuse out through the voltage gated potassium channel that open is a result of action potential. So potassium will go outside of the neuron. So this is called the repolarization of the membrane. Once potassium goes from inside to the outside, the repolarization state, this is the repolarization of the membrane, and this will continue to decrease the membrane potential of the membrane potential and reach to the point of the potassium to reach the potassium equilibrium in this phase is called the hyperpolarization phase. And you know that the electrochemical equilibrium for potassium is minus 93 MV. This is much lower than the threshold, than the membrane value of the resting state. So minus 93 MV is the equilibrium state for the potassium ion. What will happen at this point? The sodium potassium channels open, and once the sodium potassium channels open, 3 sodium ions will go out from the inside and 2 potassium back inside the neuron. So 3 sodium will go out from the inside and 2 potassium will enter to the inside of the membrane. So what will happen? Resultantly, the membrane potential will be eventually goes to the resting state. So during action potential, initially there is the depolarization of the membrane, then there is the repolarization in the membrane and the hyperpolarization of the membrane, and then goes to the resting state of the membrane potential. So what is mean by action potential or nerve impulses? Action potential or nerve impulses is actually, it is a nerve action potential is a rapidly moving change in electrical membrane potential. It is a rapid change in the electrical membrane potential from depolarization, repolarization, hyperpolarization, and again the resting, attaining the resting state of the membrane. Or in other words, it is sudden, fast, transitory, and propagating change of the resting membrane potential. Transitory means this is the temporary or short-lived state, and propagating means that these impulses will be transmitting from the axon helix to the terminal portion and then goes to the other cells or adjacent neuron. So it is a very rapid and brief depolarization of the membrane of the nerve fiber. What causes the action potential? It is action potential resulted due to the stimulus, and the value of the stimulus is expressed in millivolt. So for action potential, an adequate stimulus must be required which have sufficient electrical value which will reduce the negativity of the nerve cells to the threshold of action potential. So stimulus must have enough potential to reach the value of threshold. So we have two types of stimulus: subthreshold. Subthreshold stimulus cannot cause an action potential, and we have a threshold stimulus which have enough energy or potential to produce an action potential or nerve impulses. There are three phases: the depolarization phase, the threshold potential open voltage gated sodium channel and caused a large influx of sodium ion. This is called depolarization. And repolarization state, the threshold potential open voltage gated potassium channel and quickly diffuse potassium ions out from the inside environment. And repolarization always led first to hyperpolarization, a state in which the membrane potential is more negative than the resting membrane potential. But soon after that, the membrane establishes again the value of membrane potential. So all these about the action potential. Thank you.